Hello, welcome everybody. I'd like to invite you to go ahead and take a seat. We are going to get the meeting started right now. We have to be out of the room right at 8:30, so we'll want to make sure that we move along the agenda. My name is Zoe Carlson. I'm with DUDEC, and welcome to the Fox Canyon Groundwater Workshop. We're here to talk about the Oxnard and Pleasant Valley basins and get your feedback in the development of the GSPs. So we really appreciate you guys being here and your willingness to participate in the dialogue. I'm going to go ahead and introduce the team, starting with Peter.
I'm Peter Quinlan, hydrogeologist with DUDEC.
Hi, I'm Jill Weinberger. I'm also a hydrogeologist with DUDEC.
Ron Schnabel, hydrogeologist with DUDEC.
And I'm Kim Loeb, staff with the GMA, and I would like to recognize two directors we have in the audience today. We have Chair Gene West, and we have Director Robert Ranio. We also have our Executive Officer, Jeff Pratt, and our Assistant Executive Officer, Glenn Shepard.
Excellent. Thank you all for being here. If you haven't had a chance to sign in, there is a sign-in sheet in the back. We do appreciate you signing in. If you leave your email address, we'll add you to our email list, and you'll be subscribed to receive monthly newsletters about the work that we're doing. I'd also like to invite you to take a survey. We have surveys out there for the Oxnard and Pleasant Valley basins. That's another way, important way to get your feedback. Please wait until after the second session to fill out the survey so that you can incorporate some of the information and questions that you have in that session. We will have 3 sessions with question and answers after the second and third session. And now I'll turn it over to Kim to talk about the Fox Canyon GMA.
Thanks, Zoe. So I'm going to give just a brief overview of the Sustainable Groundwater Management Act, or SGMA, and groundwater sustainability plans. But before I do that, just a little background about Fox Canyon for those who are not familiar or not sure about it. So Fox Canyon Groundwater Management Agency was established by the California legislature in 1982 and charged with preservation and management of the groundwater resources in the lands overlying the Fox Canyon aquifer. It's a California special district. It's its own governmental agency, although it contracts with the county to staff the agency. It has a board of directors with a director from United Water Conservation District, County of Ventura, one of the a member from one of the 5 cities within the GMA, a representative of the mutual water companies in special districts, and an agricultural representative. The enabling legislation that established Fox Canyon has provided demand-side authority, and that is that the groundwater management agencies had the authority to regulate pumping and implement conservation and regulate wells, but we have not been able to get involved at all on the water supply side of the equation. The GMA has had pumping allocations regulated. There's been reporting and allocations regulating pumping since 1990. That's the outline of the GMA boundary, and you can see it covers most of the Oxnard Plain and Pleasant Valley Basin, including Camarillo, and it stretches all along South Mountain up into Moore Park. So it's a pretty big area. The basins we're talking about today, of course, are the Oxnard and Pleasant Valley Basin. Next week, we'll be doing this again, talking about the Las Posas Basin. So the Sustainable Groundwater Management Act, or SIGMA as it's known, was passed in late 2014, most significant water law in 100 years in the state, to bring groundwater into sustainable management. It did not modify groundwater rights or priorities, but it strengthened the local control and management of basins. But it did have a backstop of the state stepping in if local agencies don't take control and bring basins that are not sustainable right now into sustainable management. It introduced a whole new language of terms, but a couple of the most important is GSA, which is a groundwater sustainability agency, and GSP, which is a groundwater sustainability plan. Fox Canyon GMA was identified in the SIGMA Act as the GSA within its boundary if it should choose to be so, and the Board of Directors did choose to be so through a resolution in early 2015. And an important aspect of SIGMA is that once the Fox Canyon adopts groundwater sustainability plan, then we can now be involved on the water supply of the equation. So we won't only just have the only tool in our kit to manage pumping, but we can get involved on the supply side with our partners in the basins. According to SIGMA, sustainable groundwater management is the management and use of groundwater in a manner that can be maintained without causing undesirable results. And it defines sustainable yield as the management and use of groundwater in a manner that can be maintained without causing I'm reading the wrong thing. The maximum quantity of water that can be withdrawn annually from a groundwater supply without causing undesirable results. There's a little theme there. The undesirable results that are identified in SIGMA are the chronic lowering of groundwater levels, reduction of groundwater storage, seawater intrusion, degraded water quality, land subsidence, and depletions of interconnected surface water. And every one of these in the law, they said, if they are significant and unreasonable in the basin. And so it's up to us here and the agency to define what is significant and unreasonable within a range that is acceptable to the state. It has to be reasonable, but that's what your survey is there for, to try and gauge stakeholder input into the level of significance and unreasonableness, and ultimately that will go to the GMA board, and they will consider that as part of development of the groundwater sustainability plans. So how does SIGMA play into allocation? As mentioned, we've had pumping allocation since 1990 of different types. Well, SGMA requires that the groundwater sustainability plans include projects and management actions to achieve sustainability goals in 20 years. Our consultant, Dudek, and our technical advisory group, we have a 7-member technical advisory group appointed by the board that are working to establish sustainable yield for the basins, or a range of sustainability yield. There won't be an exact number, which is essentially the size of the pie, if you will, if the basin is a pie. And pumping allocations are management actions to address the demand side of the water balance. How do we divide up that pie? And then projects address the supply side of the water balance. How do we increase that pie so that we have more water, or at least less reductions for everybody? The groundwater sustainability plans, and there'll be a plan for each basin that's required under the SGMA Act, includes a physical description of the basins, including groundwater levels, quality, historical and projected demands, monitoring and management. It establishes sustainability indicators, and those are for each of the undesirable results we just talked about, and sets measurable objectives, which are the measurement for how you observing or causing any of those undesirable results, and interim milestones that are 5-year targets to see how we're doing on our path to sustainability. And importantly, the state recognized that we're not going to have all the information we'd like to have. There's going to be a lot of uncertainty and a lot of data gaps. So the groundwater sustainability plan has to identify and quantify that uncertainty, and then develop a plan for filling in those gaps to reduce the uncertainty as we move into the future. And the state said that the sustainability plan should incorporate adaptive management. So as there's new information or changed conditions, we can react based on that. And they also said that the plans have to be reviewed and updated and submitted to the state every 5 years at a minimum. So the plans, it's not a plan that we're going to prepare and put on the shelf, and that is the guide to move forward from here on out. It's a living document. Once we get it done, we're going to have a list of things that we need to do to move forward, to fill in the gaps, and put together the next 5-year review. So what is Fox Canyon's approach to preparing the GSPs? Use the best available science to prepare the GSPs. That's what the state's told us to do. Appointed a 7-member technical advisory group of groundwater experts and with local knowledge to provide local information, also review and comment on work product, and advise the Dudek, the GSP consultant, and the Fox Canyon board. The current schedule for the GSPs, draft GSPs to be presented to the board, is in November of 2017. That's a very aggressive schedule. And so what is the reason for that? Well, there's several. One is to address the impacts with sustainable yield-based allocation. We have seawater intrusion, we have impacts that Dudek's going to talk about, and we need to develop new allocation systems. To enable a mechanism to fund water supply projects to minimize allocation reduction. Again, I mentioned that right now we only have authority to reduce or manage pumping. Once groundwater sustainability plans adopted, we can then move into helping to fund supply projects to minimize that reduction that might be needed. There'll be proposition water bond funding opportunities. There won't be as much as we'd like, but we'd like to go after as much as we can aggressively and bring that here to Ventura County. And with the groundwater sustainability plans completed, we will have the projects and studies listed that we need to move forward with, and it'll put us in a more competitive position. It also helps us to get in front of the Department of Water Resources process, review process, We have very good communication with them, and they've committed to early review and feedback. So that's really the quick summary for those who have not been engaged. I see lots of people have been in the audience that have been engaged for a long time, but I just briefly covered what is Fox Canyon GMA, what is Sigma. It's sustainable groundwater management means avoiding undesirable results. The GSPs, they have to show a path to sustainable groundwater management in 20 years. And they have to use best available science, recognizing that there will be uncertainty and data gaps. And the schedule for completion is aggressive to move to Sigma-compatible allocation, enable funding for water supply projects, and the other reasons I listed. So I will turn it back over to Zoe at this point.
Thank you, Kim. So we can go ahead and get the second session slides up. While we're getting that up, is there any clarifying questions that we have regarding what Kim just mentioned before we launch into the technical information? Great. And I also forgot to mention there is a list of key terms at the front also with a basin map on the back if you'd like to reference that. And I'll now turn it over to Jill.
I think I should be mic'd up right now. I'm a little too restless to be able to hold on to a mic while I'm giving a presentation, so they actually attached me to a microphone. So please let me know if at any point you can't hear me. Just raise your hand in the back. I, again, am Jill Weinberger. I'm with DUDEC. I'm a hydrogeologist with DUDEC, and I'm here tonight to talk about some of the technical work that's been done towards developing the GSP for Oxnard and Pleasant Valley, specifically looking at the water budgets, the sustainable yield, and also the undesirable results discussion. I am going to give a brief overview. I know many of you are very familiar with both of these basins, but for anyone who's not, I'm going to give a quick overview of the basin and some of our conceptual model ideas for the basin, talk about the water budgets for both basins, change in groundwater storage, and how that ties into undesirable results, and then get into sustainable yield, which really actually wraps the whole concept together, as Kim has already pointed out, because sustainable yield factors in undesirable results. Quick basin overview. We're talking about the Oxnard Basin in purple and the Pleasant Valley Basin in kind of the tan color. And we're going to be talking about specific aquifers and also aquifer groups. So the primary aquifers in the Oxnard Basin are the Oxnard Aquifer, Magoo Aquifer, Hueneme, Fox Canyon, and Grimes Canyon aquifers. Those are typically grouped into an upper aquifer system and a lower aquifer system. The upper aquifer system are the Oxnard and Magoo, and the lower aquifer system are the Hueneme, Fox Canyon, and Grimes. And you'll be seeing some maps later on, particularly for water quality, where we're talking about aquifer systems as opposed to aquifer-specific maps. In Pleasant Valley, the aquifers actually transition in name, although not necessarily all of them. So in Pleasant Valley, we still have the Grimes Canyon Aquifer and the Fox Canyon Aquifer are both present and named as such in Pleasant Valley. The Hueneme transitions to being the San Pedro Formation, and the upper two units, the upper aquifer system, the Oxnard and Magoo in Oxnard, transition to being an older alluvial unit in Pleasant Valley. And there are some characteristic changes in the geology that explain why it is we changed the names, and it also determines where we have production in the different basins. It also happens to determine why we have a separate basin for Pleasant Valley. It has to do with that transition in the upper aquifer system. What I'm going to show you on the next slide, though, is that particularly in the lower aquifer systems, these basins are interconnected hydrologically. And that's important because management of one basin will affect the other basin in turn. This line on the slide here is going to be a cross-section line that I'm going to show in the next slide, going from the north Oh, they told me I would lose it. Here we go. So going from the north, just at the intersection with the Las Posas Valley Basin, all the way down and just grabbing a tiny little bit of the Oxnard Basin just to highlight this connection between the basins. This is the cross-section. It's a geologic view of the world, and you can think of it like looking at a slice of cake. If you look down on the cake, you got your nice round chocolate frosted cake. When you actually cut into it and look at it from the side, you got your layer of frosting, your layer of cake, your layer of frosting, and so forth going down. So this is that side view of the Earth. And we're actually looking here, the different colors, again, if I can pull this up, the different colors are the different aquifer units. This light blue is the older alluvium in Pleasant Valley. This is the San Pedro Formation, which transitions into the Hueneme in Oxnard. The blue right here is the Fox, and the purple is the Grimes. These lines, these dashed lines, are faults in the Pleasant Valley Basin. Faults can act as barriers to flow or limits to flow, groundwater flow in the subsurface. And so when you look at the Pleasant Valley Basin, you can maybe start to think about management areas depending on how faulted it is. But what I want to highlight here is that there is no dashed line in the subsurface here between Oxnard and Pleasant Valley. This arrow is actually where the line on the map is drawn, dividing the two basins, but geologically and hydrologically, they're interconnected. Oh, yeah, sorry. On here, this is the Camarillo Fault. Let me see if I can pull up. This one's the Camarillo Fault, and this one's the Santa Rosa Valley Fault. So when we're talking about developing a water budget for these basins, we need to factor in the flows between these basins. And I'm going to step back just for a second and talk about water budgets in general, and again make the analogy, which I think probably many of you have heard, which is to balancing a checkbook, right? When you're looking at your own finances, you want to know how much money is coming in, and you want to know how much money is going out, and you don't ever want to have more going out than coming in. That's effectively what we're doing when we're looking at water budgets. We're looking at water coming in and going out. Unfortunately, when you're talking about a water budget, you're dealing with a lot more uncertainty than you are when you're dealing with your own finances. So we can quantify some of these terms, we can directly measure some of these terms, but we can't directly measure all of these terms. This particular water budget is talked about as far as change in storage. That would be the change in the balance of your checking account, and you've got inflows minus outflows. So here we've got delta S. Here is change in storage. Inflow is precipitation, and outflow is runoff in streams, evapotranspiration, plant uptake, and direct evaporation combined. You can have flow out in the subsurface, and you can have flow in the subsurface. Now, this is a very simplistic view. These basins have a lot more terms than just this simple equation. And the more terms you have, the more uncertainty you can introduce into your water budget. I am about to show you what is the equivalent of a cocktail napkin scribble. It just happens to be done in Adobe Illustrators, which makes it look a little fancier. It also makes it pretty much impossible to read. What I'm going to show you is actually the conceptual model documenting what's coming in and what's going out in as much detail as we could without putting hard numbers on it yet. Just listing out what are the inflows, what are the outflows to each of these basins. I don't want you to feel like you have to understand every single thing on that slide. If you need a copy of that slide at some point, I'm sure we can provide it. But I'm going to highlight a few key inflows and outflows that we're going to be talking about. So again, be prepared. It's a little bit busy. This is a cross-section of the Oxnard Basin. We've seen the aquifers before. The blue is Fox, this is the Hueneme, and these are the Oxnard and Magoo aquifers in this particular diagram. All of the red symbols and red arrows are water that is flowing out of the basin. All of the blue arrows and blue symbols are water that's flowing into the basin. You can have a big, this blue looks a little more green to me right now, but this big blue is applied water and precipitation. We know that's an input to the basin. We also know that we have spreading grounds from United Water Conservation District in the forebay in Oxnard. That's blue coming into the basin. We also have red arrows here out to the coast towards the Pacific. That's flow that could go out to the Pacific. It could also come back in from the Pacific Ocean. So the key things we're going to look at here are the flow here across the boundaries with Pleasant Valley in the lower aquifer systems, and the flow at the Pacific that is causing seawater intrusion in the basin. For Pleasant Valley, we're also going to see, again, subsurface flow between Oxnard and Pleasant Valley, just like in the other diagram. And we also see, and I'm bringing this up partly because of the undesirable results section, that we have leakage from Arroyo Las Posas that has caused degradation of water quality in northern Pleasant Valley. That leakage, I should explain, the Arroyo Las Posas leakage is from discharges from wastewater treatment plants. So it has lower water quality than you would see in storm flows through the arroyo. The one thing that we have been measuring for a very long time throughout the state of California is precipitation. And in Oxnard, we actually have a precipitation record that goes back to 1900. We know that precipitation is part of our water balance. So let's take a look at precipitation and cycles of drought and wet periods. This purple line here, purple line, is the actual annual precipitation in the Oxnard subbasin. The dashed line that cuts through it is the average precipitation over that time period. And the blue line up above is actually the cumulative departure from the mean precipitation, which is a very fancy way of saying in a year that you have above average precipitation, if I can pull the pointer up again, here we go. In a year that you have above average precipitation, your blue line's going to go up. The next year you have above average precipitation, your blue line's going to keep going up. If you then have a below average precipitation year, your blue line's going to go down. It might not drop all the way back down to zero, but it's going to go down, and it's going to go down or up by the amount that you are over or under your average. And what this really shows us is that on these long-term declines, you have year after year after year. Maybe there are a couple years in there. That's a year where you had above average. That's a year where you had above average. But overall, during that time period, you had a series of below average precipitation years. And when you look at this plot, these gray lines are there to show you periods of drought. And we see this is a very standard look for the state of California, where you have cycles of above average and below average precipitation. The other thing to highlight in this is this very wet period at the end of the record. This is from 1993 to 2011, which is, of course, when we have a lot of our historical data. And that historical data comes from one of the wettest periods on record, in fact, the wettest period on record going back to 1900. I'm going to take that cumulative departure from the mean curve here, and I'm going to show you again what it looks like relative to water levels now. The cumulative departure from the mean is still precipitation. This is not a water level. This is that same blue line you saw on the previous slide. It's black in this slide. And all of the other more wiggly lines are the water levels in the basin. The reason that these water levels are going up and down so much, they're going up and down on the order of 40 feet a year, is from pumping, right? It's a cycle of when you're actually pumping your groundwater, using it for agriculture, and when you're turning off the wells. You'll see that the blue line here, going back to about 1930, and then as we pick up more wells later in time, tracks the cumulative departure from the mean pretty well. Again, you've got this annual cycling, but the overall trend in water levels tracks cumulative departure from the mean fairly well. There are a few key places where it departs from that, One is in the 1970s, and again, you'll actually see something of a departure in the 1990s, and that has to do with infrastructure and management decisions made in the basin. And those decisions have actually increased the yield of the basin through things like the Freeman diversion and spreading of water in the forebay. The last thing I'm going to point out on this is an upper aquifer system aquifer system plot. And the groundwater elevation here is shown ranging from minus 60, so that's below sea level, up to positive 60. And you'll see there are long periods of time when you have groundwater elevations that are above sea level in the upper aquifer system, particularly later in the period. In the lower aquifer system, we have not quite as long a record, right? So we're going back to 1970 here. And I'm going to point out your absolute water level elevations here are much lower in the lower aquifer system. You have, this is mean sea level at the 0 line up there, and so anything that is below that 0 line is below sea level. And that is going to start to induce seawater intrusion, which is a problem that we have seen in the Oxnard Basin and is certainly well known going back quite a long time. The lower aquifer system wells have a similar coherence with the cumulative departure from the mean, similar to what we saw in the upper aquifer system wells. So when we start to put all of the pieces that we can together, keeping in mind the uncertainty, keeping in mind that we can only measure directly so many of these, this is what we see as the historical components of recharge for the Oxnard Basin. This is based, I'm looking to Ron just to make sure I'm saying this right. This is based on the United Water Conservation District modeling efforts that are ongoing in the basin. And what we see here is that clearly the largest input is what they're spreading at the spreading grounds in the forebay. Precipitation, that one thing that we can measure, at least what's coming out of the sky, which is a little bit different from what's actually making it to the groundwater, that's only about 9% of what we're actually talking about that measured in this basin of the inputs. And seawater intrusion here is another large percentage. It's 10 or 11% of the total in this basin. We can do the same thing looking at Pleasant Valley. And the pie chart looks a little bit different here. First of all, the absolute numbers are much lower. So the inputs to Pleasant Valley are lower than they are to Oxnard. You remember that large orange piece in Oxnard was 48,000 acre feet a year. Here we've got our maximum is about 9,600 acre feet a year. The other thing I want to highlight here is this pink section, which is subsurface flow across the boundary from the Las Posas Valley. So that's that northern connection there. This is based on a rough estimate. It is from the model, but there's some discussion among the technical advisory group and others that this estimate is pretty large for what the subsurface inflow is right now, and that's an ongoing discussion. That piece will be revised as we continue to reduce the uncertainty in these estimates. What about it? Yeah?
Explain what stream leakage is.
Oh, sorry. Yeah. So stream leakage, right here, this blue piece. Stream leakage is actually infiltration from the water in a stream down through the sediments below the stream into the aquifer below it. So when you have a stream that has a groundwater elevation that's actually disconnected from the stream, that you can have flow in that stream that percolates down through the sediment and actually reaches the aquifer that's below. Many of us think about streams, the old traditional, I wish I had a blackboard now. The old traditional way of thinking about a stream, right, is a gaining stream where you actually have a water table and you have a cut in the land surface, and where that cut intersects your water table, well, that's where your stream is. That's the old standard picture of it. But you can actually have a water table that's below your stream elevation. And that's common in these sort of dry flow, dry creek beds. You're still looking puzzled, like I haven't answered your question. Oh, okay, yeah.
How come we don't see anything on there for recycled water as an input?
I can pass that to Ron. I don't know. So the answer is some of it's being used in the it's just grouped in with other inputs. Some of it's being accounted for in the agricultural input, and some of it's being accounted for in the stream leakage input. Yeah.
In 2010, the LA Regional Water Quality Control Board passed the MS4 permit here in the county. Our cities are doing stormwater recharge, and that's not included in that either.
Again, I'm not, is that? So that's accounted for in the urban irrigation section of this.
So the 700?
Yes. When we look at groundwater outflows, we're trying to take into account what those could be, right? So we can have outflow at the basin boundaries, just like we can have inflow. We can have evapotranspiration to plants, discharge to flow and tile drains, discharge to streams, and production from the basin. And just to drive this home, when we account for those and we account for our inflows, we're going to have a look at change in storage. This is, in fact, our change in storage plot. This is an annual change in storage shown in the black line right here. So this is the black line going up and down is the annual change in storage for the Oxnard subbasin. The blue bars are pumping, and the green is spreading. So you would expect that the more pumping you have, the less you would have in storage. And what you don't actually see is a very strong, it would be an inverse correlation, but you don't see a very strong inverse correlation between the blue and storage. What you do see is a very strong positive correlation between spreading, the green bars, and storage. So in the years you have more spreading, you end up with a lot more groundwater in storage. What I should have said, if I go back to this one, is this actually, these change in storage numbers include seawater intrusion. And so what it doesn't factor in at this point is the change in just freshwater storage. And we're going to work our way to get there. But these numbers right now include seawater intrusion. And so this is a cross-section showing where we have seawater intrusion in the Point Mugu area in the aquifer. And all this red striped line is an area where seawater has replaced freshwater in the aquifer. So that's a loss in storage. If we look at that now, going from our annual inflow, our annual change in storage, this year it went up, this year it was this amount, this year it was a lower amount, and now we look at the sum in the change in storage, still including seawater intrusion in this. This is again from the United model. You can see that we have periods where storage declines and it recovers and it declines, and over the time period of the model, it's down roughly 100,000 acre feet in storage from 1985 to 2015, but that doesn't factor in seawater intrusion. If we take out the estimated seawater intrusion, the decline in storage looks a little different. And what we see here is that over the long term, there has been a steady decline, a few periods of recovery, right, but a long-term decline in storage, and you're down about 400,000 acre feet in storage. About 50,000 of that is actually freshwater storage. Water levels have declined in the basin because of the drought, but about 350,000 acre feet of that is actual seawater intrusion loss in storage. If we talk about loss in storage and we talk about seawater intrusion, we're directly leading into undesirable results and a discussion of undesirable results. Kim already mentioned that there is flexibility in Sigma, and there is flexibility to allow for stakeholder and agency engagement to get together to figure out what is significant and unreasonable as far as the undesirable results are concerned. But Sigma does spell out the 6 undesirable results that you have to wrestle with in your plan. These undesirable results are reduction in groundwater storage, which we're observing in Oxnard. They are degraded water quality, which I will talk about in the next slide. Subsidence, which I'm actually not going to get into much in this discussion tonight. Surface water depletion, which I will talk about in the next slide. Chronic lowering of groundwater levels. We wrestle with this discussion in other basins where we don't actually have seawater intrusion, and how this is interrelated with change in storage, and in your basins, it's interrelated with seawater intrusion in Oxnard. But chronic lowering of groundwater levels is not something we observe in the Oxnard basin, and then seawater intrusion, which we certainly do observe. If we look at degraded water quality, we're focusing in this GSP, the agency is focusing in this GSP on 5 constituents. 4 of these are already part of the agency BMOs. For Oxnard, nitrate, TDS is total dissolved solids. It's a measure of salt in the water. Chloride, again, a measure of salt, sulfate, and boron. And this map is showing nitrate concentrations in the upper aquifer system. These are the maximum concentrations observed at a well between 2011 and 2015. And all that I'm trying to show with this map is that you see some higher concentrations of nitrate in the forebay, and that's going to be a management decision for United and for the agencies and everybody involved in the basin to understand how managing this basin will affect concentrations of nitrate in the forebay. One way that we can reduce those concentrations is to increase spreading. So how do we go about making sure that we're spreading where we need to, getting enough water to spread, and still meeting everybody else's needs throughout the basin? That's one of the issues with degraded water quality in Oxnard. In Pleasant Valley, I don't have the map, but in Pleasant Valley, production from some of the deeper aquifers has induced higher TDS water that's saltier, to come up from below. And so we have degraded water quality related to production in Pleasant Valley as well. What about depletion of interconnected surface and groundwater? This is one that we've talked about a lot. The agency is certainly working with the technical advisory group and with DWR to flesh out issues with interconnected surface and groundwater. This is a map produced by the Nature Conservancy showing potential groundwater-dependent ecosystems in the Oxnard Basin. Those are shown in green. And you can imagine, again, management decisions can impact where you'd have these potential groundwater-dependent ecosystems. Some of these ecosystems are reliant on the uppermost zone, this semi-perched zone in the Oxnard Basin that's not really used for groundwater production for agriculture and other uses. And in this area, if you start to pump groundwater adjacent to one of these potential groundwater-dependent ecosystems, you can lower the groundwater table in that area from this semi-perched zone. And you can potentially impact the ability of the ecosystem to survive in that area and access groundwater. It's another thing that has to be considered under Sigma and in any management decisions moving forward. As far as seawater intrusion, one of the solutions that has been proposed and is being examined is looking at setting groundwater elevation targets near the coast to prevent further seawater intrusion into the aquifer. These are from the United Water Conservation District GSP Light. This is a target, and again, all of this is still under development and under discussion. So please don't walk away thinking that we have set anything or anything is in stone. This is why you are here tonight, is to review some of this information. But these groundwater elevations at the coast, again, they told me I would lose this pointer, and I have. The groundwater elevations at the coast are above sea level, right? And right now, I'm gonna show you a map in a little while. Oh, there it is. Right, I'm going to show you a map in a little while, and we talked a little bit earlier about how we've got a number of wells in the Fox Canyon aquifer that have groundwater elevations that are currently below sea level. So we'd have to get the water levels back up in those wells near the coast to deal with seawater intrusion. We've talked a little bit about water budget, and we've talked a little bit about the undesirable results. And what really ties these two things together is this concept of sustainable yield. Because sustainable yield is not just the absence of overdraft in the basin. Sustainable yield factors in whether we have significant and unreasonable undesirable results. And it is, as Kim already said, it's defined as the maximum quantity of water that can be pumped annually from a groundwater supply without causing an undesirable result. It is distinct from overdraft conditions, and the best way I can think to explain this is if you've got a basin, a whole basin, where you can pump, it's a really big basin, you can pump 100 acre-feet from your basin, right? But you choose to pump 100 acre-feet right on the coast, maybe you only pump 99, but you induce seawater intrusion, right? That's not okay under SGMA. What you can do, however, is spread those wells out and pump your full 100 acre-feet away from the coast, right? So management decisions play into this. And you want to manage the basin to maximize the yield that you can get from the basin. And projects can also play into that as well. Oxnard Basin certainly has had undesirable results of seawater intrusion. And the other thing to keep in mind, because these basins are interconnected, is that production and management of the Pleasant Valley Basin can play into this. And so these groundwater sustainability plans are being developed separately. They will be written as two distinct plans, but there are discussions of how we're going to go about, how the agency will go about managing the basins coherently to avoid undesirable results. A couple of other terms here. The Oxnard subbasin and the Pleasant Valley Basin are, in fact, both high priority basins. That's separate from whether or not they're in overdraft. Priority was determined by the state based on things like population overlying the basin, the number of wells you have in the basin, the dependence on groundwater. All of those things were calculated for every basin in the state, and the state set a basin priority. That determines the high and medium priority basins have to prepare these groundwater sustainability plans according to the state. They are also, and I should point out, the Oxnard, it says here the Oxnard subbasin, it should also say Pleasant Valley Basin. They're both in critical overdraft, which is a separate designation which further pushes the schedule forward on this. So not only are they required to produce a groundwater sustainability plan, but they have to do it 2 years sooner than anybody who's not in the critically overdrafted group. Here's a map showing the upper aquifer system pumping, and then a map. I will say on this map showing the pumping, it's distributed throughout the Oxnard Basin. It's less pumping in the upper aquifer system in Pleasant Valley, and that's again because of that geologic change and the reason we don't actually talk about the Oxnard and Magoo, the upper aquifer system in Pleasant Valley. The red here is over 1,000 acre-feet a year of production. So anywhere you see a red, that's where you've got over 1,000 acre-feet a year of production. It looks a little bit different when you look at the lower aquifer system. And you actually see quite a bit of production and high volumes of production in this area of Oxnard and Pleasant Valley. And we have seawater intrusion through the Magoo Canyon in this area of Oxnard. So production here is lowering groundwater levels, and it's inducing seawater intrusion. This is a map showing those lower groundwater levels. So these are all negative numbers, 100 feet below sea level, 120, 140 feet below sea level in this basin. And that extends all the way into the Pleasant Valley Basin, although again there are faults and other things to consider in the Pleasant Valley Basin. And it's not until you get into the northern Pleasant Valley Basin where you've got this mound of recharge water that also has some degraded water quality that you get above sea level in the Fox Canyon Aquifer in the fall of 2015. Said it probably about 4 times tonight, and I apologize, I'm going to say it one more time. Sustainability really isn't just the absence of overdraft. It is tied into the other, tied into the undesirable results. And so it is avoidance of significant and unreasonable undesirable results and meeting agreed to objectives. So how is it that we're going to get to that point? How is it, oh, actually, I should take that back. I was skipping ahead. When we look at sustainability in Oxnard, we're seeing that based on the model estimates, again, it's a model that is currently being refined. These estimates will be improved. They're really, United and the Technical Advisory Group have put a tremendous effort into this. And these are estimates that we can use to start. It is part of an ongoing process, though, and they will be refined. We have a total decline in storage in Oxnard of about 6,500 acre-feet a year, freshwater, plus the seawater intrusion term. So over the length of the model, we've got about a 19,000 acre-foot a year decline in storage between 1985 and 2015. If we just look at 2012 to 2015, we've got an average of 47,000 acre-feet of freshwater storage, 16,000 of seawater, which gives us an average of 63,000 acre-feet a year of storage decline over that drought time period. The same accounting can be done for Pleasant Valley. In Pleasant Valley, when we do the accounting, oh yeah, yeah.
2012 to 2015, you're saying groundwater storage declined an average of 47,000 acre-feet a year?
Yes.
Great, thank you.
Yes. So the question, in case you didn't hear, did I mean to say groundwater and storage declined on average 47,000 acre-feet per year? And the answer to that is yes. In Pleasant Valley, we can do the same accounting. And when we do that, we actually see that there is an increase in groundwater and storage over that time period, over the 1985 to 2015 time period. That increase, however, you have to adjust a little bit because we have that bright pink pie slice that I showed in one of the earlier charts. That's the estimate of inflow from the Las Posas Valley Basin. And that estimate we think is too high. Again, it's being refined, but we have a 4,000 acre-foot per year increase if we take this 8,400 acre-feet per year inflow as our number from Las Posas Valley. Over 2012 to 2015, still including that 8,400 acre-foot per year inflow from Las Posas, we have a groundwater storage decline on average about 13,000 acre-feet per year. So here's where I'm going to step back and I'm going to actually say again, huge effort done on the part of the Technical Advisory Group and on the part of United Water Conservation District. United Water Conservation District has really been pushing their model. And when we look at that model, the estimated change in production that would need to happen would suggest, from the current model understanding, keeping in mind that there is uncertainty in this, that in both Oxnard and Pleasant Valley, the combined pumping would need to be reduced to about 60,000 acre-feet a year. However, that model is assuming that they will be able to maintain historical spreading, and it also assumes that no projects would be included to increase the sustainable yield of the basin. So this is a starting number to review. The United model is being actively modified. It's addressing comments from the technical advisory group, and these numbers we anticipate could change as we reduce the uncertainty moving forward. How do we get through all of this information and sort of start to define a path towards sustainability in these basins? If we have a hypothetical sustainable yield for our massive 100-acre-foot-a-year basin that I like to refer to here, in 2020, we still have a lot of uncertainty. So our sustainable yield, what we think it is this black triangle. But the uncertainty is quite large, and it's represented by the black bars around that triangle. We can reduce our pumping to within the realm of uncertainty. So we're reducing, but we don't have to instantly drop it to a single number of sustainable yield. We have to account for uncertainty. Sigma allows us to account for uncertainty, and we want to do this in a way that's going to minimize the economic disruption that could occur through reductions in pumping. And as we refine our estimates going forward in time, every 5 years, Kim mentioned those 5-year updates, we're actually going to reduce the size of our error bars, and we can again plan for reductions in pumping that may be necessary moving forward until we finally have to get to sustainability 20 years out. So this is a long-term process. Each agency is going to have to establish measurable objectives along the way. These are interim milestones. They are physical things that we can measure, water levels in the basin. They have to be things like water levels in the basin. They have to be established for each sustainability indicator, and they have to be based on quantitative values. So they have to be things we can measure. And they will provide a reasonable margin of operational flexibility. They will take into consideration the historical budgets, the long-term trends, periods of drought. But here we go. They have to be commensurate with levels of uncertainty. So it's written in to Sigma. If we look at a slightly more complicated, but probably more realistic view of the basin over the long term, we can also start factoring in projects that can increase the yield, right? So our goal is to increase the sustainable yield and minimize those significant and unreasonable, undesirable results. In this case, we have the sustainable yield is here in blue, and maybe 5 years in, we have a 2,000 acre-foot-a-year project that comes online. So we have some uncertainty by these dashed lines here. With time, the uncertainty, the distance between those dashed lines gets smaller, but we also can factor in projects that would increase the sustainable yield over time. Yeah?
What is your factor for climate change and a warming planet?
Yes, that's
long-term drought.
That's a very good question. So the question is, how do we factor in climate change, a warming planet, long-term drought? That is accounted for under Sigma. We're actually developing those sections as we speak, but you're required to look 50 years out for climate. DWR, I believe, has promised actual climate projections at some point. I think they promised them last January, if I'm not mistaken, and they haven't published them yet. So we are wrestling, and we'll be talking through with the agency and how to best address that in the plan, but it's absolutely required to be addressed in the plan.
It's the 800-pound gorilla in the room.
So it's the 800-pound gorilla in the room. That's right. Yeah. And you know, I will add to that that there are other factors in this that could, right? This is the rosy view, which is a good way to look at it. We can come up with projects. We want to come up with projects to increase the sustainable yield, but other management actions can occur in the basin if we have reductions in spreading in the forebay. Some of these projects are going to be offset by reductions in spreading. So this is just to highlight that this is a long-term process. We can impact the yield of the basin. We do not need to know all of those projects today in order to get this plan in. Projects can come in and be better fleshed out in time. Yeah.
As sea level rises,
Yes.
does that then raise the level that we have to maintain in terms of fresh water to keep the pressure to keep the saltwater intrusion?
Yeah, another good question. So the question was, if, as sea level rises, what does that do to the groundwater elevations that we need to maintain, that the agency needs to maintain along the coast? The factor, yes, the groundwater elevations need to rise commensurate with sea level rise, but the projections that I showed you included a 1-foot rise in sea level relative to today's sea level. Yeah.
So I have a question in regards to the November deadline for the submission to the board for the approval. If you don't have from the state the temperature and precipitation numbers for the climate change calculations, how can you submit it?
Well,
Maybe we should take those questions at the end, and then the panel here can address some of those questions.
I would encourage you to bring that up again. The one thing I will say to that question is how are we planning to address it, is that we've had really good communication. The agency has been in fantastic communication with the Department of Water Resources, and the Department of Water Resources has indicated that they don't want to be the factor that's holding plans back. And so if you come up with a reasonable way of addressing this in the plan, the department is going to be willing to look through that. But I'll leave that to a more thorough answer for Kim, so please raise that question again. I know there are a lot of hands going up, and I actually really appreciate that, because the next slide is opening it up to questions. Before I fully open it up to questions, I do want to thank, there are a number of members of the technical advisory group in the audience. They have really advanced this process, working with them and with the agency. We've certainly learned a lot about these basins. We've learned a lot about what we don't know about these basins. And I just want to emphasize this is a long-term, ongoing process. So thank you very much for your attention.
Thank you very much, Jill. So yeah, we are going to open it up for questions now. We ask that you do come forward. I'll hand you the mic right here. If you can please just state your name if you would like to say which basin you're particularly interested in or affiliated with before you state your question. That'll help the panel in answering. So if I can have our first speaker come forward. Any questions? All those hands that were up. Everybody's shy now. Jill will be one of the people answering questions. Can ask her again.
And before we get into questions, so I'd like to acknowledge our board member, Steve Bennett, who arrived late. And I do appreciate Jill recognizing the tag. I failed to do that. We do have several members. They put in countless hours volunteered time that have been critical to the development of the GSP. And we've Terry Foreman, Brian Bondi, and Tony Morgan here in the audience, so we really appreciate their efforts and all the rest of the tech.
Any questions? Come up, please come up.
I'm Jürgen Gramko. My question was, you had a slide that said the estimated sustainable yield was about 60,000 acre-feet, no projects, with the assumption that surface recharge was going to be about the same. So in the no projects definition, do you have no moving of pumping around, or is that with moving of pumping around?
That was United's model. That did include moving of pumping, but I think what she meant was there were no additional water supply.
Okay, so it does include moving pumping.
Right. So that was the presentation you've seen from them before.
Well done.
Would anybody else like to come to the front? If not, we will pass around the mic. Keely's going to help us out. Okay.
just going to repeat the question that I just asked. I know there's several pieces of information we're waiting to get from the state. One is the final for the groundwater-dependent ecosystems, and also the temperature and precipitation for climate change. So my question is, I don't understand, and I'm sure there's others, I hope you'll tell us, because you know the timetable better than I do, but how can we submit a plan without the state-provided information?
Well, as Jill said, we've had a lot of communication with the very senior DWR staff on this issue, and what they've told us is that we should use the best reasonable assumptions to move forward. They don't want to hold us up. They're not going to reject our groundwater sustainability plans for reasonable assumptions. And if there's a lot of daylight between our assumptions and what they ultimately come out with, then those will be addressed in the 5-year update. It can be updated before the 5 years. Yes, 5 years is the minimum update. The board could decide to update the plan at any time there was some significant change that warranted a change. So there's no minimum amount of times, but 5 years is the presumed frequency, and that's the maximum amount of time that can go between updates. I'd also like to say that the uncertainty regarding diversions off the Santa Clara River and the constraints that United has to operate on for their groundwater recharge efforts likely, I think, is going to be a much bigger level of uncertainty and effect to our management of groundwater than the impacts of climate change here in the Fox Canyon area.
Okay, so the other question is, in your presentation, you listed several management decisions that would have to be made by the board or incorporated into the plan. One of them, what I saw was perhaps no pumping along the coast there because of the seawater intrusion. So are those management decisions going to be made before the plan is submitted, after it's presented to the board, or how are we doing this?
You want me to take that one too? So, well, we have 20 years to show progress or to get to our sustainable yield, which is to avoid those undesirable results. So we will include in the plan those projects that we can identify and flush out and know that we can implement within a period of time. But the work doesn't stop once the GSP is finished. That's going to have a whole laundry list of things that we will need to do, including additional studies and development of projects. So there's two types of projects that are being considered. One is water supply, and the other is infrastructure. And so there's a lot of infrastructure, but we have a lot of infrastructure. There's pipelines that do move water from one place to another to reduce pumping in the more sensitive areas, and we need a lot more infrastructure so that we can move that over time. But the plan's not going to identify all those. I think that.
When I talk about projects, I'm talking about management decisions, which would be board decisions, and not on projects, but on, for example, what you're saying about the saltwater intrusion. If they decide that a certain area along the coast should not be pumping, are we making that decision when we're for public comment when they present it to the board in November, or are we making that, when are those management decisions being made?
Management decisions will be made by the board, yes. Oh, okay. Right. Those will start to come to the board in around October meeting, and so we'll be talking about possibility of some special board meetings as well because of our time frame. So stay tuned.
Kim, on that last question about adoption of the plan or submission to the board, it might make the point that a much more important part of this is adopted by the board. Once the plan is adopted by the board for the GMA, the board has the ability to establish replenishment fees. Once the replenishment fees are established, then it's possible to start planning and building projects. And that's a much more critical date, and that can happen much sooner than the DWR process.
Very good point, Jeff. Agreed.
Can we put the PowerPoint back up, please? The session 2.
What I'm looking for, if you can, the slide that shows the ramp down and how, because of the level of uncertainty, it ramps down, gradually over time. We're getting close. All right. Back one. There you go. So as you presented this, you mentioned that this allows us to minimize the ramp down early to try to minimize the economic impacts. And that's a good thing in terms of trying to minimize the economic impacts. But what my question is while we're minimizing the economic impacts, we may be maximizing the undesirable impacts of saltwater intrusion, et cetera. Is there any analysis taking place that will say by maximizing the environmental impacts, we're actually going to create a bigger problem that is a harder problem for us to fix 20 years down the road, that will maybe mean our sustainable yield actually has to be lower because we let so much more salt water in or whatever? Is that level of analysis taking place? What I would want to know is if we cut, instead of 5% in the first 5 years, if we cut 12% in the first 5 years, would we be reversing something that would actually give us a better sustainable yield 20 years down the road? Is that analysis taking place? Is that too difficult? Is it possible, et cetera? That's my question.
Yeah.
I can start you start to address it now.
Yeah, I'm not sure if I can address it to your satisfaction because there's so many unknowns, so many uncertainties that I was just going to say that there's so many uncertainties in that number that we're only creating more uncertainties in the effects. So to be able to really quantify that, I don't know if we can do that for this GSP. I think that's got to be something that's looked at very hard in the next 5-10 years because it's very tough to dealing with the uncertainties we already know we have to answer that question.
I could see how that would be difficult certainly by November, but is it something that's really important that we check out? Because it seems like we would want to be careful to not shoot ourselves in the foot by waiting too long to sort of do that analysis. So I guess what's the level of urgency on that? How important is that? And how do we do that? Maybe we go to a larger sustainability fee so that we can get a project in to get a reversal before, like, I don't know, maybe saltwater getting to a certain spot means it then spills into another area. And if we would have gotten a project in a little sooner, that's my question.
So it is a very good question, and I believe that what we envision as staff and will be bringing to your board is that there is a lot of work to do once the first GSP has been adopted. It's really going to get our hands around the data gaps and the level of uncertainty, and there's monitoring infrastructure we're going to need to put in, monitoring wells in key places, and we're going to have to do follow-on studies to help to understand that kind of question much better. And so we will be coming to your board once we know more about where we need to go with that, which will be a pretty short time frame from here, and then move forward with studies. And then, as we discussed before, this is what we know now. identifying what we don't know, the path to get there, and in the next few years, we expect to be needing to do a lot of work to really get much better handle on it and be able to answer those questions and adjust the path that we're going and understand what projects will work and affect our ability to maximize the yield and minimize those undesirable results.
Sigma also calls for the setting of interim milestones. And so as part, if you take the gradual, less disruptive approach and you think through what the interim milestones need to be and you don't hit them, then you can adjust the glide path. You still have to do the analysis you're talking about, but it's not just wait 20 years and hope that we...
Do we have any kind of idea what those interim milestones should be?
We're still developing them.
The question I have is in regards to seawater intrusion. You've put up a slide there that approximately 350,000 acre-feet of available storage has been swallowed up by seawater intrusion. Is there any estimates going forward based upon this ramp down projection that you're showing there as to whereabouts the seawater intrusion front would be 20 years from now and how much land that would encompass?
No, we don't, but I think it's my understanding that a model is currently still being worked on, and those numbers are still being developed by United Water and their modeling of the seawater intrusion. So even though we don't have an answer today, it's actively being worked on.
Thank you. Hi, so I'm curious to know the timeline and process for public comment once the drafts are out. How long will the public have? What will be the fate of those comments? Will they be published? Who has a responsibility to respond to them? Will there be published responses? How will that interact with the board's own evaluation of the draft plan?
Yeah, we keep a record of all the comments and a table of the comments that come in and our responses to those comments, and those will be made available to the public. We send out notices as soon as the material's uploaded onto the website. So if you may need to get on, if you're not on the list now, to make sure you get on the list so you get that notification.
I guess I'm thinking of, I'm sure there's going to be some sort of formal comment period once the entire kit and caboodle is delivered.
That's correct. There'll be another formal comment period once the GSPs have been drafted.
And how long will that be?
60 days, I believe, is the comment period for the public after it's been approved by the board.
And there will be another workshop when that is, when the draft is goes out for public review, and that at the front of that 60-day review period to collect comments, and then DUDEC will take all those comments and address them before finalizing the plan.
Thank you.
Are there any other questions?
First of all, thank you for your time, GMA staff, consultants, directors. There was brief mention of the plan being able to account for prolonged dry periods. The gentleman here up front, and we mentioned the 800-pound gorilla being a prolonged dry period. I mean, the inverse is actually also true. The possibility of prolonged wet periods is just as possible as prolonged dry periods. So I imagine your plan will also account for consistent above average rainfall periods to ultimately and potentially increase a sustainable yield?
What the plan is required to account for and what we will account for is the projected climate change, right? So that can include both periods of drought and periods of above average precipitation. what we're still working on right now in the absence of data from DWR is how best to address those given published estimates of what future climate will look like in this area. But yeah, it's a climate change projection as opposed to just a prolonged drought projection.
So to do that, we would be simulating, or we would be relying on United's model to simulate the next 20 or 30 or 50 years with varying climate. So it may be that we're using the last 30 years of data and adjusting temperature and precipitation to come up with a different amount of, to look at recharge from precipitation and run that through the model to get the recharge and have the same periods of drought that we observed. I mean, in one of those early charts, there was an 18-year drought from 1918 to 1936. But there are other periods, the average, the average is about 7 years for the record we showed earlier.
Do we have any other questions or comments? I'm going to remind you that this is why we're here. We're here to get your feedback and understanding of your perspective to incorporate. So we really appreciate those that stood up and spoke and had comments and questions. You can also submit comments, and if we can move the slide to session 3, you can also submit your comments via email. And the next session, we're going to talk a little bit more. Thank you for the question about the opportunities for comment engagement. We're going to talk a little bit about that next. But I really want to make sure we have a couple more minutes if there's any last questions on any of the technical information. Yes?
I just have a question on the survey. Oh, sorry. So it says to turn it in, but we could also send it to you afterwards. So we could distribute it to other owners that aren't here. Okay.
Yes, absolutely. The question was about the survey. We're going to make that available on the Fox Canyon website. So if you know somebody that should be filling out that survey that's not in the room, they can definitely do that. We're also recording the meeting, so please encourage people to go to the website and watch the meeting and fill out that survey. And if you're not already on the email distribution list, please add your name and your email in the sign-in sheet, and we'll be sending out information through that also.
So I just thought of one more question. Is in the body of the plan, is there going to be some matrix that says with these indicators, here's where we've got to unreasonable, before that it's kind of reasonable, and here we're okay? Like, are those kind of metrics going to be developed and published in the plan, or is that a decision for the board to say what's unreasonable?
Yes, it will be a decision for the board to decide what's significant and reasonable with stakeholder input. What the consultant and technical advisory group and staff are working on is how do we measure these things. There's a range, obviously, of these that are going to be acceptable to DWR, but in terms of where we focus on, and so that will be ultimately a board decision. Did that answer your question? Okay.
Any other last questions before we will have another question and answer session after this presentation. So if you do have a question or a comment, please jot it down so you remember to ask it at the end. So just quickly, again, we mentioned it's really important to have your feedback as part of the plan development. And we do have all of the drafts available for public review concurrent with the Technical Advisory Committee review. We put them on the Fox Canyon GMA website. There's a GSP-specific page on the Fox Canyon website where all the draft sections and draft documents are held. We also, as Kim mentioned, send out an email notice when there are new documents available for review on the website. So here's just a brief overview of the outline of each of the GSPs that's being developed. And on the website, you'll see there's a screen grab on the right. There's a separate folder for each of the GSPs that's being developed with the drafts for the sections and chapters being populated as we develop them. Today, we're focusing on Chapter 3 for the Oxnard Basin and the Pleasant Valley Basin. Kim mentioned we'll be having a workshop next Wednesday to focus on the Las Posas Valley Basin GSP, so please do come and attend that and provide your feedback at that workshop. And the Arroyo Santa Rosa Basin GSP is currently on hold while the GSA formation moves forward. And there are currently all of the documents on the left, which I don't expect you to be able to read on this slide, because I encourage you to go to the website and look at them, and you can download them on the website. There are sections, draft sections of Chapter 1 and 2 in there for the Oxnard Basin. As we mentioned, we're developing Chapter 3 with your input and feedback from this workshop and your comments that we receive. Also, the Pleasant Valley Basin, these are the documents that are currently available on the website. Again, draft sections of Chapter 1 and 2, and we're working on draft sections of Chapter 3. Yes. There's just a couple more slides if you don't mind, but please don't forget. So I mentioned the monthly electronic newsletters that are sent out to the email distribution. Again, if you leave your email on the sign-in sheet, we'll include you on that. You can also email the GMA website, the email address to be added to the list if you would like to subscribe to the newsletter. We also send out the drafts that are available. We'll have stakeholder workshops, as Kim mentioned, the one next week, and then another one when the draft plan is available to incorporate your comments at that phase also. We also have the surveys, which we'll make available on the website. And this is our email address. If you have comments, you can submit them in writing through the email address. You can also be asked to be added to the list, and this is the Fox Canyon website. Kim, did you have anything else to add on this?
No, I think you covered it, Zoe. Thank you.
Okay, now I'll entertain questions.
So my question is, once something's published and posted on here, if there's a change made in TAG or anywhere else, is it redlined so you don't have to go read through the whole document again and figure out what actually changed, or how are you addressing the changes?
Right, they're not redlined now. Based on some feedback we got at the last technical advisory group meeting from, I can't remember who it was, but somebody made public comments, asked for kind of a chart that showed the sections and what their date was and when Dudek was looking for comments in, and we could probably track when a revised version of that goes up there. But I'm not sure that we're going to, through the individual section development, be putting red lines up there.
Other questions? They can be about anything we've discussed today if you have other questions or comments. Yes.
I'm a bit curious as to the purpose of this questionnaire. Those of us who've been pumpers in the Oxnard and Las Posas areas for years have been under various allocation systems, historical reduction, emergency ordinance E, and so forth. And the questions are so generic and not nuanced at all. I'm curious as to how you feel that these questions will provide any value.
Thank you for that. Do you want me to? I can talk a little bit about that. So what we were hoping is we hope for participation from people that have a lot of knowledge about the basins, and we hope that you can submit specific comments also that reflect that knowledge to incorporate. We also wanted to make sure that we give other people that maybe are stakeholders but don't have as much experience with groundwater an opportunity to participate in the GSP development.
That's right. So I think, for those folks who are really close to it, these do seem maybe a little unnuanced, I suppose, but there's a lot of folks, and we want to get folks who, all stakeholders, who may not be operators and have as much knowledge as you may have. And so it's an awareness tool. It's a tool to get people thinking about these sustainability indicators, the undesirable results, and get some feedback from where people, stakeholders have greater concerns or not. And so we can kind of summarize that input and provide that to the board as they can consider weighing the level of undesirableness and significance of each of the sustainability indicators or undesirable results. They're sort of interchangeable terms in the SIGMA. Does that answer the question?
I understand your response, but when you look at these questions, you're supposed to grade them 1, 2, 3, 4, or 5, or answer them yes, no, or unsure. It doesn't seem to be any ability there to add, and, would you be willing to support a replenishment project? Would you be willing to? Of course, everyone's going to say yes to that, but that doesn't mean anything because no one knows what it costs. No one knows what the benefit is. It's so superficial.
On the back page, there's an area for adding more comments if you have specific comments, but there'll be obviously a lot more stakeholder involvement in specifics as we start moving towards considering specific projects. This is a first step in providing awareness and getting some general feedback, and so we'll see what kind of response we get and what we get, but there'll be plenty of opportunity down the road for sure to be involved with considering and understanding and any kind of projects that might be considered to be moved forward with.
Could you all speak a little bit more to the stakeholders you're seeking to bring into this process that are potentially not currently involved? Ventura County has not historically lacked for opinions about water in terms of having stakeholders already present in the process. So I'm curious as to who are the voices that need to be added or heard from in your mind that have not historically been.
Well, that's a good question. Now, in terms of this, we do mail and email to everybody who's a pumper within, has a well within Fox Canyon GMA, has received communications from us on this process. But there are other folks who are reliant on wells that are not necessarily operators. There are we try and engage some of the disadvantaged communities through their mutual water companies, other water users, people who may not be quite as plugged in. Everybody who relies upon water for their domestic, their business, their agricultural, their industrial use, or environmental use, all are stakeholders in this process. So we advertise, we talk to the different community groups, we send out emails, we try and plug people in. So if there are stakeholder groups that you're aware of that would like to participate or we should reach out to that you don't think we're getting in touch with, let us know.
Other questions?
Just going back to the question, I think it was 2 questions ago about uploading documents and red lines on the website. Kim's absolutely right. We don't have red lines on there right now, but we will provide a responsiveness matrix, to a responsiveness discussion of all of the comments that we received and how they were discussed in the GSP.
Well, I'm just trying to figure out if the documents will change, because, you know, if you're constantly having to compare one to the other to see what the changes were.
Right. No, I understand that.
That will probably be done between the draft and the final, right?
Yes.
So do you want to mention that? Yeah. So in these working drafts, as they're undergoing review by public, by TAG, by staff all at the same time, that's a process that would be pretty cumbersome. But from the final draft, when the final draft goes out for public comment and gets responses, and then those are taken into account and finalized, then that will certainly show the changes that have been incorporated due to comments that were received. So you'll be able to track that between the final draft that this lady here was talking about and the final, when it's finalized after the 60-day public comment period.
Other questions? Comments? Okay, well, thank you very much for being here. We really appreciate you taking the time out of your evening. Thank you to the panel for being here. Please do make sure you leave your email address before you leave. We'll go around, Keely will go around with some envelopes to collect your surveys on the way out, and we hope that you can spread the word about the meeting next week also. Thank you.